All right, everyone. Thank you for waiting a little bit. Welcome to our session for today. We're going to be joined by our good friend Claudio Acquaviva to talk about how to manage a hybrid microservice implementation using Kubernetes. It's a pleasure to be here with you today. We've been working in a series of webinars for, this is our second edition, I believe, right, Claudio?
Yeah.
On the topic of Kubernetes, microservices, and service mesh implementations. We have some interesting topics for you today. We're going to be talking a lot about how to properly visualize your architecture and implementation using Kubernetes in a hybrid environment. So without further ado, Claudio, I'll let you get into it.
Thank you, my dear friend Alex. And thank you very much for having me here today for this tech session. It's a pleasure talking to you again. Yeah, and today I'd like to talk about the application infrastructure modernization process using Kubernetes. More than that, in a hybrid microservice implementation. So not just Kubernetes, but also other platforms at the same time. So the session is assuming that you and your company have already got started to move away from your current enterprise service bus, SOA and SOAP-based infrastructure to a containerized microservices-oriented environment. Of course, there are so many perspectives when talking about a process like this, but today I'd like to focus on the two of them. The ESB to microservice migration process itself, and when you're trying to do it, you're gonna face multiple platforms options in the marketplace right now, where Kubernetes is just another one available today. So to get it started, so let me talk about the enterprise service bus to microservice migration process first. So to get it started, here's a reference architecture, trying to get it very in a simple way, kind of architecture where you have the both worlds inside the same environment. So on your left, you got your current or your old-fashioned ESB running your SOAP-based services. And then on the other hand, you got the brand new microservice architecture you are currently focused on. So the question is, how should we proceed with these new microservice development as we are retiring with this retirement of the services running on the current enterprise service bus? So basically, we got three main strategies over here. On your left, we got the first one. It's called a strangler. So in a strangler strategy, you got a brand new layer on top of your current ESB and your microservices environment. And then the strangler is responsible for routing requests to one or to the other environment, depending on the requests. Over time, you are retiring, as I said before, you are retiring your current ESB services and as you are implementing the brand new microservices, functionally speaking, similar to the services you got currently in your enterprise service bus. And then eventually, you will be able to retire your enterprise service bus once all the services already, you got all the services already running in your microservices infrastructure. The second strategy, we call it a splitting services. So from the consumer perspective, they're still dealing with the enterprise service bus, but behind the scenes, we are, again, replacing the current services implemented running inside the enterprise service bus in the new versions in the microservice fashion. So again, over time, you will be able to retire the whole enterprise service bus layer. Again, you got all the, functionally speaking, all the services already available, deployed in your in your new microservices infrastructure. And then in your right, you got the third strategy. We call extracting services. This time you got two completely separated independent infrastructures. The first one, the current one, again, based on your enterprise service bus. And then you got started implementing your new microservices applications in the brand new infrastructure as well. So it's up to the consumers going to the first one or the second one infrastructure, depending on the functional they are requiring this time. So regardless the strategy you're taking now, eventually, talking about implementation this time, eventually you're gonna have a architecture like this, or even simpler architecture right now. So you got the API gateway, and I'm using the Kong API gateway this time, just an example implementation. Highly recommended to work very close to your identity provider. The identity provider is responsible for a number of things like user and application authentication, multi-factor authentication, tokenization, and so on. And the API gateway is responsible for validating the tokens that have been issued by the identity provider. And then thereon, if everything is fine, the requests will be considered okay to be passed to the services or microservices layer, where again you got both infrastructures, enterprise service bus and the microservice architecture. The thing is, when you take a look at a diagram like this, you might be wondering who is taking care of the non-functional capabilities, like high availability, scalability, elasticity, resilience, and so on and so forth. Who is taking care of these non-functional requirements? As a matter of fact, nobody is. So you need something else to help you out with these non-functional capabilities. If you go to the marketplace today, you got several options available. If you go to Microsoft Azure Cloud, for instance, you're going to find Service Fabric, for instance. If you go to AWS, you got EC2s with all the scaling groups, you got ECS. But the marketplace, we're seeing another option getting traction, even more, getting much more traction when compared to the other options right now, which is Kubernetes. Kubernetes is there to help you out with these, mainly because of these non-functional requirements. Again, to help you out with the high availability, scalability, elasticity, and so on and so forth. So why Kubernetes? So to put it simply, because you got a standardized environment. Differently when differently than you got with these other options I mentioned before. Kubernetes is a standard platform. Something like, doesn't matter where you are, doesn't matter where you're going, it's going to be a Kubernetes distribution there to take care of those deployments, and then again to implement your high availability, your scalability, elasticity, and so on and so forth. So our deployment, this version over here, it's right now a little bit more, slightly different when the first one we got. Now we are addressing the capabilities we mentioned before. So Kubernetes is bringing to the table, out of the box, these capabilities to help me out in these non-functional requirements. For instance, self-healing, it's Kubernetes capability. So self-healing is responsible for resilience. That is, let's say one of these deployments, we call it pods. That's the Kubernetes terminology. Let's say one of these pods going down, crashes. Self-healing is responsible for bringing it up again. So in this sense, you have a high availability functionality in place. And then another very, very important capability provided by Kubernetes, it's HPA, or horizontal pod outscaler. So the number of pods might vary over time along the way, depending on the traffic that are coming in. So if you are experiencing a high throughput, you might be have a large amount of pods in place. And then over time, when the throughput's going down, the Kubernetes, more precisely HPA, will be able to terminate some instances of your pods because you don't need 3, 5, only 2 pods will be enough to support this kind of throughput. And then finally, load balancing. Not just load balancing, but Kubernetes has got a service virtualization capability. So in this sense, the consumers are consuming your Kubernetes service, and behind the service, you got your collection of pods, and then Kubernetes not just virtualizing the pods for you from your perspective, from your consumer's perspective, but also dealing with the load balancing capability. So again, why Kubernetes? Because of that. Very, very important platform. Of course, you can achieve this kind of implementation in other options in the marketplace right now. But then again, we're talking about a standardized option provided by Kubernetes. So if going a little bit further than this in terms of API development, as you can see in the previous slide, all my pods are running inside the very same Kubernetes cluster. It's good, but that could be better. That could be even better. Something like, you got several, not just several instances of the API gateway, but these instances running in totally different infrastructures. So for instance, you got microservices running on premises in a regular Red Hat Enterprise Linux. You got microservices running on AWS Cloud. You got other microservices running on Azure Cloud. The thing is, the API gateway should go where your microservices are. That's the point. This is very, very important. So we are not forcing you to implement the API gateway in this or that infrastructure. As a matter of fact, you are deciding where you want your API gateway running right now. So in order to do it, the API gateway has been divided in 2 sublayers, let's say. The data plane, the green boxes here. The data plane is responsible for the API consumption itself. So every time you got a consumer trying to consume the API and therefore microservices behind it, the consumer should go to data planes. And the second sublayer is the control plane, the blue one. The control plane, that's the layer the admins go in order to do admin tasks, like defining a new API, defining policies for each one of these APIs, like rate limiting policies, cache policies, security policies, and so on and so forth. And then how many data planes are going to have over time? I really don't know. It really depends on the throughput you got in a given time. So again, in Azure, for instance, you might have Azure Kubernetes Service taking care of these data planes over here. And then you got another infrastructure to taking care of these other data planes over there, and so on. Again, the point is, you want to go hybrid. You want to go with deploying your microservices in multiple environments instead of dealing with a single one. And then because of that, you should have a more flexible API gateway in order to support your microservices, whatever they are. The other topic I like to talk about is the differentiation, the differentiator regarding the API gateway layer itself, which you can see up here again, and the microservices layer. As you can see, the microservices is there, but nobody's taking care of the protection of the security of microservices. So this topology over here, now we got two separate layers of Kubernetes, or if you will, two completely separated Kubernetes clusters. The first one taking care of the, again, the API gateway layer, or edge computing, if you will. And then they're really focused on concern about this kind of coarse-grained policies, like global rate limiting, user application authentication, IP blacklist and whitelist, and so on. No codes, no microservices running on this time, only the API gateway, protecting not just the microservices environment, but also any other environment you have in your backend. Again, ESB just would be just another example here. And then at the microservice layer, you are concerned in the fine-grained microservice-oriented low-level policies, like a specific microservices rate limiting, for instance. That would be another example. So this kind of separation, very, very important. Think about the real world deployment. Different teams taking care of these different layers, different time frames, different environments, and so on and so forth. So it doesn't make sense to have these a single layer taking care of both requirements, the edge computing requirements or API gateway requirements and the microservice requirements. That will be highly recommended to have these worlds separated. Going a little bit further on these microservices, very, very important to keep in mind that we're talking about microservices, you're talking a highly distributed and dynamic environment. That is very, very common. Question like, given a let's say you got already 20 microservices in place, already deployed. Very, very common question like this. Giving a microservice, let's say microservice number 7, how many instances you got of this given microservice? Now, microservice number 7. We're not talking about monoliths anymore. We're talking about, again, a highly distributed and dynamic environment. The answer to my question is, I don't know how many instances I got of this given microservice. Again, it's totally dependent on the throughput the microservices are experiencing at a given time. If the microservice is being highly consumed, chances are going to have a multiple instances of this given microservice. And then the number of instances of these microservices is going to vary along the way. That's the, and why is that? Because you want to, you are experiencing different throughputs along the way. You want to deploy canary releases. You want to go and implement this A and B testing and so on. So that's kind of dynamic environment we're talking about this time. As you can see, totally different when comparing to the old-fashioned enterprise self-service environment. So we are solving some problems, but on the other hand, we're introducing new ones. Like for instance, from the microservices 1 perspective, how many instances of microservice 2 you got in a given time? It's hardly to manage. It's hard to manage this kind of thing. Not just the number of instances, but the load balancing, the traffic control in terms of encryption channel, access control, and so on and so forth. So again, we are solving some problems, but introducing new ones. The thing is, implementing these new capabilities inside of microservices, that wouldn't be a good design. As a matter of fact, the marketplace is proposing right now a new pattern where you got all these capabilities: service registration, discovery, load balancing, traffic control. All these capabilities are compiled, totally isolated in a proxy. And therefore, the microservices doesn't even know how many instances of microservices 2 he needs to deal with. So that will be a proxy responsibility. So this kind of pattern, that's the basics of your what we call the service mesh pattern. So in this sense, for each one of these services you got in your deployment, your microservice architecture, you're going to have a proxy running very close to it and taking care of all the non-functional requirements I described before. Again, load balancing, encrypted channels, service discovery, and so on and so forth. That's the proxy. They're part of the one of the sublayers of the service mesh pattern. We call it data plane. So data plane, in other words, data plane is a collection of the proxies you got in your microservices architecture. And then there's another layer, we call it control plane, responsible for the policy definition. So every time you want to define a policy, you go to control plane to define this policy, and this policy is going to be published, broadcasted across all the proxies, all the data plane you got in running your microservices architecture. So same topology we got in the API gateway layer, we are reproducing the same topology we had there inside our microservices infrastructure this time. So for instance, let's say you don't want the microservice 1 to talk with the microservice 2 anymore, just because. That will be a traffic permission policy, let's say. So you should go to the control plane and describe this policy to the control plane saying, microservices number 1 won't be able to talk with microservice 2 anymore. And then this policy will be published across the data planes, across the proxies you got, and the microservice number 1, the next time microservice number 1 we try to call microservice number 2, is going to receive an error because the policy you just described it. Just one example of communication between the microservices you can take control over. So in a sense, Kong has provided another product. It's called Kuma, the service mesh implementation. It's one of the several service mesh implementation we got in the marketplace right now. I would say the two main capabilities provided by Kuma is that, first of all, it's we call it universal service mesh. So you might be wondering, where are these services are running this time? Totally independent of the platform. You might have some microservices running on Kubernetes. You might have some other microservices running outside Kubernetes, and then you still have the very same service mesh implementation. Another capability provided by Kuma is the flexibility and the ease of use. Instead of dealing, as extensive, a long list of CRDs, that's the custom resource definition we used in Kubernetes. Instead of dealing with extensive list of CRDs, this time we got a very, very basic, very simple to use CRDs, talking about a little bit more than 10 CRDs only. More than that, Kuma is can allow you to implement a distributed service mesh. So in this sense, you're going to have a control plane, a global control plane layer, and then you're going to have a local control planes, more than remote control planes, and more than remote control planes. You're going to have services running in specific what we call zones. So in this sense, that will be totally feasible, possible to run your control plane in, for instance, Google Kubernetes engine. And this zone over here, this collection of services running in Elastic Kubernetes service from Amazon, for instance. And then this zone number 2 would be running on Azure Kubernetes engine. So 3 clouds being used for your self-mesh deployment, totally visible. That will be another differentiator in terms of self-mesh implementation or distribution you got in the marketplace right now. So to summarize, that's our beautiful microservice and edge computing topology right now. So the 3 layers over here, the number 1 up here, we got the Kubernetes, for Kubernetes infrastructure, taking care of the edge computing API gateway layer. Again, making sure that requests that are coming in, they're totally fine and can be passed to your microservices. And then the second level abstraction, we got another for Kubernetes, playing the security level for your specific for your microservices. And then the third level abstraction, that will be the self-mesh, taking care of the microservice to microservice communication. For instance, this diagram over here is showing you a canary release. So microservice number 1, it's dealing with the 2 versions of your microservice number 2. One of them is considered the canary release. And the self-mesh is taking care of the load balancing, the percentage of the requests coming to the one or to the other microservice you got already deployed. So I'd like to call my friend Alexandre. Now he's going to talk about a little bit about the digital bank APIs, a use case, describing a little bit about the digital banking API right now. Please, Alex, take it over.
All right, thanks, Claudio. So we're just going to give you guys a quick example of how this could work in a more business-oriented context in the real world. This is a product that we at Opus are running in a couple of clients right now. So basically the idea is how can you create a service infrastructure to support all different kinds of digital banking products with the intention of making the move towards a more open banking solution in the market. So we're talking about servicing your customers, be them merchants, if you're maybe an acquiring bank or maybe a payment facilitation service provider. If you're providing digital accounts or credit card accounts for your account holders, or even if you have sales channels and integration partners that might be, bringing in product through your APIs, which is a very common use case for low origination services. So in this context, we're talking about having a very large number of internal services. So you can imagine to support all these different kinds of products, you might need to run a lot of different kinds of functionalities that might even support different kinds of products. So when you're talking about KYC services or onboarding services, those functionalities are going to be useful for multiple situations. So you want to have those domains properly isolated and running side by side in order to support your product offerings to your customers. So in practice, all of these are going to be running as services that are going to be orchestrated and talking through an event bus, so you can have event sourcing and properly manage your transactions, but also talking with service providers, which may or may not be legacy services, but these are your core services on your financial institution structure. So you could be talking about your core banking, your credit card processing service, your loan management, ERP, some sort of credit analysis provider, or your payment processors, anything that is not your that might be processing your core infrastructure, right? So these microservices, they're actually doing the job of talking with your client APIs, be it either apps or third-party partners. They're the ones that need to have a clear domain definition, and they need to be able to scale, and where they're the ones that pose the challenge of being managed, and they're the ones that need to be flexible in terms of service composition and in terms of scalability to make sure that you're bringing the best service offerings to your customers with the proper performance, right? So in this context, Claudio, if you could please shift to the next slide. Thank you. So this is a more higher level view of the technologies that we're working with. So we're talking about Kong as our API gateway, which helps us a lot organizing our domain APIs, because we need to have a very clear definition of and a clear vision of who's accessing each API and at what throughput and what permission. So like Claudio said, we're always talking directly with our service provider, which we're using Piccolo currently. And Kong is the entry point to talk with all of our internal services. And we can use a multitude of protocols, but GraphQL has been a huge accelerator for us. But in the backend, you could be using services in whatever language, be Go, Python, or Java, or anything that you might want to use. And also, we use Kafka helps us as our event bus as well. So in this context, you can imagine that having so many service domains, the challenge of scaling and monitoring all these services becomes bigger and bigger very fast. So that's where Kuma has been a lifesaver in order to make sure that we have full visibility of all the services that we're running and how we can actually change policies and make sure that we are releasing stable and trustworthy versions of every single service to our end users. And as you can see, we have the flexibility of having visualization tools for both business dashboards and also infrastructure dashboards, all connected to Kubernetes and all the data that is being streamed through our services. So that allows you to decouple all your legacy services that are running in such a way that if they're not ready to scale, you're capable of having a buffer between your end users and your services. So this allows you to both have a better ability to scale and also better flexibility to change service providers if needed. So you reduce your vendor lock-in by having an architecture like this. But the bottom line is this reference architecture allows us to drive innovation, scale our partnership efforts, experiment, and enhance security and control, all while expediting integration with your legacy. So, Claudio, if you have anything to add, this would be the end of our presentation, and we'll now be ready for questions. Thank you. So, we do have a couple of questions here. One of them, Claudio, we did mention a little bit about canary releases, and people do seem to, have questions in terms of how do I know if a canary release is good for production or not, and where should I look at in this tech stack to know to get those metrics and that information to know if a release is good for production.
Yeah, it's a good question. As a matter of fact, that's one of the reasons why you want to run Canary, because you want to make sure that even though the Canary, the brand new version you got for a given microservice, you have to make sure that it is robust enough to go to production. And that's one of the very, very nice strategy to make sure that you got the best implementation in your production. So the thing is, usually the Canary release, you get started with, let's say 5% of the traffic is going to the Canary. And again, just going back to my slide over here, and then this kind of thing that you want to define. So you want to inject the policy inside your sidecar saying that all the requests going to microservice number 2, in my example over here, 95 of the requests should go to microservice number, the current release, first of all. And then only 5% of the canary release is going to the canary release version, of course. The most important thing is that from the microservices 1 perspective, you don't even know what's going on in terms of canary release, in terms of percentage, in terms of load balancing, in terms of requests going to these or that release. So you don't even know it. You don't need to change the microservice 1's code. So the microservice 1 is still talking to the microservice 2. And then over time, you are changing the percentage of your load balancing. And then eventually, the canary release is gonna take care of the 100% of the requests. In other words, you're ready to retire the current microservice 2 because the 100% of requests are going to the canary release. So the canary release will be ready to be promoted to the brand new release. So in order to make sure that everything is fine, as you did, and you're showing your slide over here, your diagram over here, very, very important you have these of observability or visualization perspective of what's going on with your microservices. Mm-hmm. So products or tools like Prometheus and Grafana for real-time monitoring, and Elastic Stack, where you can see Kibana over there taking care of your beautiful dashboards. But then you're taking care of not just for the real-time monitoring, but checking the log processing as well. So these tools over here, the visualization or observability stack, they're very, very important to provide information regarding what's going on with your microservices, more precisely with your canary releases. And then we'll be having more information. You can change your canary region policies over time, and then go through the promotion, the canary release promotion at the end. So very, 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 very important capabilities. So both API Gateway and Service Mesh, the microservices, and Service Mesh, if you will, both layers should be able to support this kind of tools. Again, Prometheus, Grafana, and Elastic Stack, that will be just examples of such tools. You have, so many other options in the marketplace right now to help you out with these monitoring, log processing, managing, and so on and so forth.
All right. Now a question more specific to Kong as a tool and its authorization capabilities. Would it be possible to use Kong as an identity provider without using a separate service?
It is. I wouldn't recommend it. It's totally fine, but I wouldn't recommend it. So this slide over here is very, very important. So first of all, we are just following. When I say I don't recommend it, I'm just following one of the most, I would say, the most important principle in computer science: separation of concerns. So the API Gateway is responsible for protecting your assets, digital assets. The user authentication, user application authentication, that will be part of another layer of your corporate architecture. These other layers should be the identity provider. So as I said before, the identity provider will be responsible for user and application authentication, multi-factor authentication, so on and so forth. Just following the principle, the separation of concerns principle. For corporate applications, we don't recommend to mix them up. I mean, to inject authentication capabilities inside the API Gateway layer. We don't recommend it because all the reasons I have described. So of course it's doable. If you want to do it, of course it's doable. You can inject, as a matter of fact, you can inject some identity providers, capabilities inside of API gateway. I would say that will be good for some use cases only, not for all of them, some use cases only. But it's very, very important to keep in mind that you are dealing with exceptions here. So in generally speaking, I would say, general recommendation to at least to try to keep these layers apart. User application authentication on one side, API consumption on the other side. Of course, the API gateway is responsible for validating all the tokens issued by the identity providers. Very, very important capability. It's not because you have been authenticated by the identity provider, you are good to go. It's not like this. The API gateway is responsible for validating your requests and then checking if your token injected in your requests are still valid, are still good to be passed, to be transferred to your microservices or services environment. So in this sense, the microservices should be considered all the requests good ones to deal with. They don't need to spend some time or to validate the tokens, because all these kind of validation have been done by the API gateway layer and working together with the identity provider also. That will be it.
All right. So one more question regarding gaining a level of maturity in terms of using a service mesh. So if I'm running a Kubernetes cluster today, what sort of overheads should I be expecting from running a service mesh on top of it, and what would be the challenges to move towards that?
In terms of overhead, in terms of resource consumption, I would say very, very little. We're talking about the sidecars, talking a little bit about the implementation of these sidecars, of these data plane or proxy, if you will. For instance, Kuma uses the best sidecar in the marketplace. It's called the Envoy. I would say 9 out of 10 service meshes implementation in the marketplace use Envoy sidecar to implement the data plane layer. So one of the main reasons why is that the sidecar, the Envoy implementation, is very, very light. So in terms of resource consumption, very, very little consumption. I would say one of the most, I would say more important than to be concerned about the consumption, resource consumption thing, is that to design your microservices the right way. Very, very common to companies just wrapping up services in Docker images and call them microservices. As a matter of fact, they are not microservices. They're just monoliths wrapped up as Docker images. So I would say that in order to go in a real microservice implementation, you should take care of these microservice design process to try to identify the right microservices, and therefore to implement them in a much lighter way, and ready to be deployed in this highly dynamic environment, and then that will be it. So if you don't, in other words, if your microservices doesn't scale, if the microservices don't scale, like you're not dealing with the multiple instances of a given microservices, service mesh won't be a problem for you. As a matter of fact, wouldn't be solving any problem, because you're not deploying several instances of a given microservices. So why should you care about load balancing, service discovery, and so on and so forth? So again, in summary, I would spend a lot of time trying to identify the right microservices before trying to implement them and deploying them in a Kubernetes infrastructure or any other infrastructure you might have in mind.
All right. One more question. Talking about Kuma specifically, how does it have the same observability as other service offerings in the market, something like C or Kiali? So what sort of observability tooling does it provide?
Yeah, Kuma, the focus of Kuma is to be the most flexible submesh implementation in the marketplace. That's the point. That's why one of the main capabilities provided by Kuma is a kind of distributed submesh. So from the observability perspective, as a matter of fact, the recommendation is to integrate with your observability infrastructure you have already in place. So Kuma is able to integrate as you can imagine, with the Prometheus or Elastic or Zipkin for tracing, for instance, all these open tracing, as a matter of fact, any open tracing based tools and so on and so forth. So in this sense, if you got a already in place, just like you do here in these diagram over here, you got already Elastic in place, so that will be okay to get your microservices, your submesh, if you will, integrated with Kibana or Prometheus with Grafana and so on and so forth. So yeah, the same way the API gateway itself provides you, I mean, the integration with these exactly the same visualization / observability layer over here.
All right, and one last question. How does Kuma as a service mesh compare to other offerings in other service mesh tools in the market?
Yeah, I've already described some of them, some of these differentiators. Again, number one, I would say the two main ones, again, the capability to go distributed. So again, logically speaking, we're still dealing with this very same service mesh, but then again, the services themselves are running multiple environments at the same time. So again, we are not forcing you to choose Kubernetes to implement your service mesh. Of course, Kubernetes, that will be, one very, very good option in the marketplace to implement it. But again, we're not forcing you to do it. So that will be one of the main capabilities, not just to have these hybrid service mesh implementation, but also to choose on-premise, several cloud vendors to implement your service mesh. And then in the background, you can decide to migrate a service mesh running on-premise to the cloud or vice versa, if you will. Other capabilities that will be very, very much simpler to deal with when you compare it to Istio, for instance, very, very popular service mesh implementation, I would say. But the Kuma service mesh implementation is focusing to be a much simpler service mesh to deal with, instead of again dealing with the dozens of CRDs. We're talking about only 10, 12 CRDs in order to get everything done. That would be it. Another thing is that we have it's an open source project, and we have donated the open source project to CNCF, which is the organization taking care of providing the I would say the cutting edge, the bleeding edge infrastructure in the marketplace. We got it at this time, so it has been donated to CNCF a couple of weeks ago. So in this sense, we're going to have a much more robust implementation. A lot of other contributors to implement the future versions, features, and so on and so forth. That will be it.
All right, good stuff. Thank you, Claudio. All right, everyone. So that about wraps it up. Thanks everyone for joining us today. Claudio, if you have any closing statements.
Yeah, thank you. No, just I want to thank you all one more time. Thank you very much. It was a pleasure talking about this kind of topologies, technology, so on and so forth. I hope it has been helpful for you guys. Thank you very much. See you next time.
All right, I'm sure it will be. So for everyone that joined us today, remember to follow us in our social networks on LinkedIn mostly. And we will be following up this webinar with a survey that helps us making sure that we're bringing the best quality content for you guys. So please, if you can, remember to answer those when we send them out. And again, we will be sharing the content of this presentation with everyone that joined us today. And I'd like to thank Claudio again and see you guys next time.